Okay, problem one, plot the points and create the pre-image triangle with vertices -2, 3. So we'll go -2 and up to 3, which is right there. Let me fix this. Erase that out. Use the pen. That's -2, 3. That is point M. Then we'll go N, -3, 5. So actually that is -3, 5 is going to be right here. That's going to be N. Let me move M back over to -2, 3. So -1, 2, and 3 right here should be M. All right, and then P is -5 all the way out here and up to right here. That is P. And it says to translate the coordinates to M prime, N prime, and P prime if we translate it right 6 and down 3. So we'll go to each one and just go right 6. So we'll do M first. 1, 2, 3, 4, 5, 6, and then down 3. 1, 2, 3, and we're sitting at 1, 2, 3. We're sitting at 1, 2, 3, 4, 5, 6, and then down 1, 2, 3. We're sitting at 4, 0 here, which will be M prime, and it's 4, 0. Okay, and then N prime is right 6. 1, 1, 2, 3, 4, 5, 6, and down 3. 1, 2, 3. We'll be here for N prime. Okay, and the last one is P at -5, 2. And we'll go right 6. 1, 2, 3, 4, 5, 6, and down 3. 1, 2, 3, and this down here at 1, -1. Okay. So to explain what you did to each of the coordinates. Well, in each of the coordinates, we moved it right 6 spots horizontally and vertically down 3. And so for each one of our x, y's for our coordinates, we actually did the following. We went right on the x-axis, so that's +6. Oh, erase that. And then we went, get that straight. So we went right 6. And then for the y part, we actually went down 3, and down on the y-axis is a negative. So that's what we did. We went to the right 6 and down 3. That's problem number 1. That's what we did with the coordinates. Problem 2. List coordinates of triangle ABC. Well, coordinate A is over 1 up 2. So it's 1, 2. Coordinate B is over 4 up 1, and coordinate C is over 5 and up 4. So over 5 and up 4. So that's listing the coordinates for A, B, and C. We've done that. Check mark. Okay. Now it says reflect the triangle ABC over the y-axis here. That's what I'm taking this to be, y-axis, and list the coordinates of the vertex A prime, B prime, and C prime. Describe what happened to the coordinates from the pre-image to the image. Well, if we reflect across the y-axis, and this is our y-axis right here, going down. We're going to reflect across that. I'm going to put the new one in blue. And so across it, we count from our points, we count to the line of symmetry, which is the line we're reflecting across. There's one space. We'll come over, and this is going to be A prime right here. A prime. We do C, 1, 2, 3, 4, 5, and we would count 5 on the other side, and we would come out here, and that'd be C prime. B prime, we're going to count 4 to the line of symmetry, and then 4 over here for B prime, so B prime. Now, how about our A prime, B prime, C prime? Well, A prime is at -1, 2, -1, 2. B prime is at -4, 1, and C prime is at -5, 4. And so what happened, describe what happened to the coordinates. Well, if we reflect across the y-axis, we can see that all the x values change. We change the sign. A was 1, it became positive 1. B was 4, it became negative 4 for my x. And C was 5, 4, and my x changed to a negative 5. So when reflecting across the y-axis, we change the sign of x. Now, it says reflect the triangle ABC over the x-axis. So let's put those, we'll put those in red, okay, and we reflect. So our x-axis is going to be, we'll do the x-axis in blue here. And so here's our x-axis that we're going to reflect over. And so we're just going to count to the x-axis and then go on the other side the same distance because it is our line of reflection. So 1, 2, and then 1, 2. So right here is going to be A prime down here. Now, we use A prime again because we did not come from the A prime going to here, so this will still just be A prime. It's a whole different problem, not going to a composite transaction where we would do, or transformation where we would do one and then the other. B is 1 space away, and it'll be 1 space away on the other side. B prime. And then C prime is 1, 2, 3, 4. It takes us 4 to get there. And so 1, 2, 3, 4 down. And that's C prime. And again, this is B prime. Also good writing there. And then we take our coordinates. Well, A prime down here becomes, when we reflect over the x, we change the sign of y. So it becomes 1, negative 2. B prime, we change the sign of y, it becomes 4, negative 1. And C prime was at 5, 4, and it now becomes 5, negative 4. So reflecting over the x-axis, we can see that the sign of each one of the y coordinates has changed. All right, moving on. List the coordinates of A, B, C, D, and we're going to reflect those over the line x equals 3. Well, okay, the coordinates of A is, here's our origin right here, and it's negative 2 and up 1, 2, 3. So it's negative 2, 3. B, point B is at 1, 2. 1, 2. C, point C is at over 1 and up 5. So over 1, up 5. And D is at 0 and up 3. So 0, 3. Now it asks us to reflect over the line x equals 3. Well, where is the line x equals 3? Well, that line x equals 3 is right here. So we go to where x is 3. And again, all values on this line for x will be 3. So every point that we could plot, the x value would be 3. We would have right here 3, 0, then 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, negative 1, and 3, negative 2.
Good afternoon, Mr. Warner. Please report to the testing vault. Mr. Warner, please report to the testing vault. Thank you and have a great day.
So now if we reflect across that line, we're just going to count, again, we're just going to count to the line of symmetry and see what our primes would be. So for C, we're going 1, 2 spaces, and then 1, 2 spaces on the other side. So C prime will be here. And C prime is going to be 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5. So C prime is going to be at 5, 5. Okay, B prime is 1, 2, and we'd go 2 on the other side, 1, 2. So B prime is right here, B prime. Now we see over here that B and C were lined up vertically together, and over here they are the same. So B prime is going to be over 5 and up 2. So B prime is over 5 up 2. Now A prime is going to be 1, 2, 3, 1, 2, 3, 4, 5 spaces there, and then 1, 2, 3, 4, 5 there. So our A prime is going to be here, and that's going to be over 8 and up 1, 2, 3. So A prime is going to be 8 and 3. And D prime is here, and it's 1, 2, 3. And we'll go 1, 2, 3 here. There's my D prime. Okay, and it's over 6 and up 1, 2, 3. So it's at 6, 3 over 6 up 3. Now you'll notice that when we reflected across the x and the y, our numbers in here stayed the same, but the signs changed. When we reflect across a number that is not or a line that is not either the x or the y axis, such in this case where it is the line x equals 3, that our coordinates are actually going to change. They're not going to remain the same. So any reflection over the x or y axis, your coordinates will stay the same. The numbers will. The signs will just change. Any other line is actually going to change the coordinate numbers. Okay, now we have a reflection over the line y equals x. And this dotted line here is the line y equals x. Okay, and you should have learned in algebra why that is the line y equals x. Okay, it's because the slope is 1. So if we had y equals mx plus b, and that's our slope-intercept form. If our slope is 1, which is up 1 over 1, up 1 over 1, then we have y equals 1 times x plus b. Well, 1 times x is just x. And then we have plus b. Well, in this particular line, b is our y-intercept. Where is the line intercepting the y-axis? At 0. So we essentially end up with y equals x plus 0. And of course, we don't need to have the plus 0 because it's not going to change the value of x. So we end up with a line y equals x. Now, how do I reflect over this line? I count diagonally. Where I've been counting vertically and horizontally, when I go to the y equal x line, I need to count diagonally then. So here's how that works. I'll start with n, and I count diagonally across the box. So there's 1, and then to get to the line of symmetry, I only go halfway across this box. So I've gone 1.5 boxes. So on the other side, I have to go 1.5. So what I do is just, when I go a half, I just immediately flip the other half. So 1.5, well, there's a half, and there's 1. So that's going to be n prime. Okay, let's do k. K is only half away till we hit the line of symmetry, and so we go half on another side. So that's k prime. M, well, m is 1.5, so I go a half, and then I go 1, and that'll take me 1.5 away, and that's m prime. And then L, I'm going 1, 2.5, so I take my half on the other side, and then I still have to go 2 more. 1, 2. And here is L prime on the other side, okay? Now, what happens to the coordinates? Well, the original coordinates here for L was -2, 1, 2, 3. So L was -2, 3. K, the coordinates for K were 1 and then 1, 2. So K was over 1 up 2. M was over 0 but up 1, 2, 3. So M was 0, 3. And then N was over 2 and up 1, 2, 3, 4, 5. So N was over 2, up 5. Now, what changed when we go to our primes? Well, when reflecting over the line y equal x, let's see what changes. So L prime now is over 3 and down 2. So it's 3, -2. K prime is 2, 1. M prime is 3, 0. And N prime is 5, 2. So what happened to the coordinates from the pre-image to the image? Well, if you look here, we can just say that they just flipped inside the parentheses. What was -2, 3 becomes now 3, -2. And then what was 1, 2 becomes 2, 1, 0, 3 becomes 3, 0, and 2, 5 becomes 5, 2. So what we can say is if we reflect the line y equals x, then our original xy becomes yx. And that's the rule. Now back real quick to